Hello everybody, today I would like to practice more the Java reflection. For that I've created a class user, okay, and I added a few attributes. If you saw my previous videos, I always use this class user in some of them, and usually I just need username and password, but for this example I added a few more properties like email, birth date, active and age, and the main idea is to collect several different data types, because the idea here is just to create a JSON serializer, which means that we want to take the user and serialize to JSON. JSON has some challenges. The one is when you have string data type, you should use the quotes for the value. But for instance, for date, use the quotes, but you have to serialize the date in a specific format. For booleans, you should serialize without quotes, but it should output something like true or false, for instance. And then you have the number data types like integer, long, float, and so on. And for those, you don't need to use the quotes. Okay, this is just a simple POJO, plain old Java object user with gets and sets, and with a toString. Sometimes it's useful to output the values in troubleshooting scenarios, for instance. Okay, so the main idea is just to create, as I said, a JSON serializer. I split in 7 versions. I will do a video for each one of the versions because it seems simpler. It's just like extracting the field names and the values, but there are a lot of challenges to be accomplished. One of them, for instance, is let's say you have an object inside an object. Imagine that you have a user and user has an address, and the address, by the way, can have other composite objects. So how can we interact and recursively go through all these objects and serialize to JSON? This is one of the challenges. The other challenge is just to serialize collections and arrays. It seems simpler, but it's not, because the collections, they have objects, they contain objects, and these objects, they are serialized also, which can contain collections inside and arrays and so on. Then we have the enumerators. For dates, for instance, maybe we want different formats. When we are serializing a date, maybe we just don't want only the year, the month, and the day. Maybe you want in a different format. So we want to specify these formats, and there are several ways to do that. We can go on a first approach as the standard way, just the default way of Java. But then we want to, for instance, use annotations to change the format for specific data types. And as you can see, it seems simple at first, but it's not simple to implement a serializer at all. Okay, so I split this in 7 videos. This is the first one. This first one, we will serialize strings, local dates, Boolean, integer without any format. We just go and try to understand how to collect this data from the user, collect the values, check what is the data type, and serialize correctly, and we can build the output string in JSON. Then on the further videos, okay, I will do a simple class with additional data types and their respective formats configurable, like dates, floats. Maybe you want a float, but with only 2 decimal places and things like that. Okay, then the version 3, it's about the enumerators. Then composite objects. Objects inside objects is the most challenging one. Then we can add collections and arrays. I added the collections and arrays at this step because the collections can have other objects inside. So I prefer to use on this version for on the fourth video to do the composite objects, so it will be easier to implement the collections and arrays. And then we can use annotations to, for instance, ignore specific attributes. Maybe we want to ignore the attributes whose value is null, for instance. Maybe we want to change the format of a float or a data type. And on the latest video, I will use the getters to get methods. It's not the same as reflect on fields, because now we have 2 things to consider. One is to find the get method, invoke the method, and understand in this case, it's just the only these 2 things. I was already thinking about the set when we want to deserialize, but let's stop here. First, we'll do these 7 videos about just the serialization. Then we'll do the deserialization, and that it's even more challenging than to serialize. One of the advantage to learn how to serialize an object, it can open a lot of doors to other kind of systems. For instance, if you think about an object relational mapping, you want to take an object, for instance, and generate an insert, update, or delete. It's the same concept. We are not generating a string with the fields and names in JSON, but we are generating, for instance, a string saying insert into the name of the class. Then between parentheses, you want to put the field names, and then the word values, and then the values of these fields. So the engine, it's the same. It's just the string that it's outputted, it's different. And there are other scenarios where the concept of serialization is very useful. Maybe we want to serialize to formats like, for instance, XML, YAML, and other formats that exist, and we want to do the opposite. And additional to that, you can always learn from developing this kind of systems, because now when there is an error in this kind of frameworks that use the serialization mechanisms internally, you can use that knowledge to understand better the errors that can be outputted when you are using or developing your application. So let's go and see how can we serialize a very simple object. So I've created here an instance of the user with these names, just string, an email, a local date. We can add other data types like local date, time, and for instance, the date. I choose the local date, but on the version 2, I will add the other date data types provided by Java. And now we have a boolean here, and we have an integer. And in later videos, I will add others like float, doubles, and so on. And what we want is just to call a class called JSON Serializer, which has a method called serialize using fields version moon. I'm adding this suffix version moon so we can then later compare the versions and what are we adding to the previous version, so we can understand what changes when we add new data types and dates and so on. Okay, so let's play. It will be simpler to start with the output and check the code later. Okay, so as expected, I have the username, the name of the field, and the value here. The same for password. This is a very interesting attribute, because later we can use, for instance, annotations and say you should ignore this kind of fields when we have a secret, for instance. We can use an annotation, say please ignore this field. We don't want the password to be serialized. Or maybe going a little bit further and apply a method, say if you have a password, for instance, generate an hash or something. It's an hash. It's not dangerous, because when you serialize an hash, the only way to check the password is if you already know previously the password, and you can compare if you hash the password with the result on the log. Sometimes we don't want to ignore the password, the value. We want to output something, and in those cases we can just output an hash following a specific algorithm, because the hash is, as you know, it's a one-way operation. You cannot reverse the hash to the original name. Okay, but that's encryption theory. Then we have the email here, then the birth date, the local date, and by default it is serializing like this. In this version, I'm not formatting to a specific layout for the date. Then the boolean, you can see that there are no codes here, and then we have the integer 40, which doesn't use codes also. Okay, so let's see how to implement this. So we passed an object, not the class, then we are printing the user JSON that is generated by the Serialize using fields version 1. So it's very simple, the code. There are a lot of code, but it's if you look at the patterns, they are all almost the same. Maybe you can refactor and clean a little bit some of the code here, but this is the first version. Let's go straight to the point. So we received the object. First thing is just to get the class of the object, because I want to reflect on the object and ask to Java, okay, what are the data types and the field names, because I will need them. I will need, for instance, the field names to fill the left part of the JSON here, and I need the data type to understand if I have to generate codes or not when we have numbers, for instance, booleans or other data type. So we have here the object, let's call it object. Then I instantiate a string builder. It's a common way to concatenate strings. And the first thing on the JSON when we are serializing an object is just to use an open bracket here. Okay. Then we go through all the fields. So we get the declared fields. We only need the fields from this class. The difference, again, if you saw my previous videos on reflection, you can, for instance, use get fields without the declared. But in this case, or in those cases, what will happen, it will get the fields or the parent fields of this class. And we don't want that when we are serializing. If you want, okay, we can use it, but then the serialization can be a little bit more complex. Imagine that I want to just serialize a specific class, and then on the other side, it is expected only these fields, not if you are inside a specific hierarchy of our class. But okay, there are a lot of discussion here. I will not enter on this discussion now, but of course you can always argue, okay, but if you are inheriting, maybe you should use the fields, and the other service that is using this service should know about those fields and so on. Okay, there are a lot of discussion here, but in our case, let's just use the common fields of the class, not the parent ones. Okay, let's return to the serializer. So now we start with this symbol here, and now we want to do a loop to generate these parts, the key value, okay, then the comma, then again key value, then comma, and so on until we reach all the fields, the latest field. Okay. So now the first thing we should do is just field set accessible true. Otherwise, we cannot access private fields. The reflection mechanism in Java forbids access to the private fields unless we explicitly request so, like set accessible true. Okay. Now just a common pattern. We always want to start with this code here for the field name, add the get name here, okay, and then append. If you want to see this in a different way, you can always do something like this, and you can check that we are code name of the fields, okay, and code, and then we just add this symbol, this separator here. Okay, and now we'll check the data types that we are using here. In the next video, I will provide for the other data types, but for now, I'm just targeting the common ones. The first one, if it's a string, again, we just add the code here, the value of the object, and this is field get object. We put the get, and we put here the object, meaning that get the value of this field in this instance, okay, that is passed here on the parameter, as you can see here. And then end code, because it's a string. If it's a number, and I provided a method only for this, because you always have the primitive types and you have the wrapper primitive types, and you should consider both. And to be a number is first, when we provide the field, we get the type of the field, and then this is for the primitive. You can see that it's a byte here, short, int, long, float, double. If it's any of these primitive types, just return true. It's a number. But maybe you are using a wrapper number. It's not byte, it's capitalized. The B and the E, rather than int, it's integer, and so on. So in that case, we can use this technique, which is because all the number data types in Java, the wrapper runs all of them inherit from the class number. And this is a very trick thing that we can do. It's a very useful, and that we can always say, okay, if the type here, it's assignable for number, okay, it's a subclass of number. In this case, maybe it's not correctly what I'm saying, but if it's a subclass, so the number is assignable from, okay, that's what it says. So it's a number. If it's a wrapper, but it can be an integer, a float, a byte, a short, a long, a double, and so on. Even being a wrapper class, but if it's assignable for a number, we can infer that it's a number. Okay, so if it's a number, we don't use the codes, something like this, 40. And if you go to the user, you can see that it's a wrapper one, integer here, not int. That's different. Int dot class and integer dot class, they are different types for Java, at least from the reflection point of view. Of course, at the end of the day, there are the auto boxing and int or integer. It's the same thing when we are assigning values, but for instance, the integer allows nulls and the int doesn't. Okay, let's return to the serializer. So we already saw for the string. Now for the number, and it's the same. We just get the object, we append. Now if it's a boolean, in this case, if it equals to the boolean, and now you should be careful about this. It should be boolean like this, okay, and booleans capitalized like this. Okay, boolean and boolean, where the b, it's different. This is the wrapper class, this is the other class, and you should use both. If you remove, for instance, this one in our user, okay, it will not work because this is the native part, not the wrapper part of the boolean. Okay, so we just, and in this case, we can call directly get boolean, because the get boolean will print true or false as we expect. And then for the local date, of course, we could add the other ones like local date time or date, but in the end, the date will be a little trickier because there are a different way to serialize the string. The local date and local date time belong to Java 8, and Java 8 created a very good way to manage the dates and things like that. But the date, it's the old school, can be trickier to serialize correctly. But in our case, we are just using the local date, and the local date here, it will print something like this. And if it's a local date, we want to use the codes, we can use again the get, and again and finish with the code. For each field, we are always adding the comma here, but the latest one doesn't have the comma because we remove it at this line here. Okay, it's a tricky thing that we usually do when we have a loop and we will need to concatenate, and we remove at the end because we know that for sure there will be, if there is at least one field, at least one comma or an additional comma exists and should be removed from the end. Okay, and then we finish with this symbol here, and we return the string. Let's run it again. There is no difference. Okay, it will be the output. Just change something here. One, and it is serializing as expected. This is our first version, as I said before. It will be a very big, large video if I try to add all of these versions, and it's more complicated than it seems at first. Mainly when we reach this version 4, where we have to do a recursive calls, meaning that we want to serialize this object, and because there exists other objects inside, we should serialize them, and we don't know at first how deep is this tree. I can have an object that inside has another object, which by the way has another object, and so on and so on and so on. Imagine that you have a tree, for instance, a file system tree. That's how complicated this can be, and probably we will need to refactor a little bit the code so we can split and reuse several parts of the code. But I will not go into details how to implement, just to left here a little bit of taste of the future videos. Hope it was useful for you, this video. Hope you are following my reflection videos. In Java, I think they are very useful, very constructive, and I think it can, if you are not used to use reflection, I think it can open your mind regarding the tools and the thinking process for future projects. Please, if you will, like the video, subscribe my channel, publish it. I usually I don't publish my channel on YouTube or my videos in other places. I just like to develop it and show what I learn. But I hope you like it and you can do it that for me. and I thank you in advance. So see you in my next video.